Hello and welcome back. Integration and enrichment. Definite integral. Okay, integral from 0 to pi over 2, the sine of x times the cos of x, the whole thing over cos to the 4 plus sine to the 4 of x dx. Where do we start with this? First thoughts, this actually scares me. I feel like crying when I see something like that. I have very bad experiences with kind of integrands that look like this. That have got me to the wall at times. First of all, I want to show you something which doesn't quite work, I think, here, just looking at it, is those who are practicing with step papers, the Putnams, the integration from the MIT integration Bs or whatever you call them, the American stuff. You might be familiar with this particular technique, and I want to show you this. So just as an introduction, normally for something like this, you might be considering substitution such as, I don't know, y is equal to pi over 2 minus x, which sometimes they do work. So the intention is, of course, to reverse the limits, first of all. So the dy will be, of course, the same as minus dx. And the limits will swap. The 0 will go to pi over 2, and the pi over 2 will go into 0. And if you see what's going to happen to this integral, it's going to become, let's put equal dot dot dot. This is not formal workings because this is not what I'm going to do in my solution. It's going to reverse the limits, first of all, pi over 2 to 0. And I'm going to get, of course, the sine of pi over 2 minus, that's my x, so that's going to be the sine. Let's write it here for people to see. People, of course, that haven't seen this particular technique. Pi over 2 minus y, so pi over 2 minus y, cos of pi over 2 minus y, and of course everything is going to be the cos to the 4, and all the same arguments now. They're all pi over 2 minus y plus sine to the 4 pi over 2 minus y, and my dx, of course, now it's going to be a minus dy. So if we examine really what's going to happen in there, first of all, I'm going to lose the minus in here, and I will reverse the limits back to the original form. That was part of the plan for those who are familiar with this kind of techniques. Okay, now the sine of pi over 2 minus y is, of course, this is standard facts from your trig, is of course the same as, oops, I'm writing sine there, it should be the same as the cos of y, and the same thing, the cos of pi over 2 minus y is the same as the sine of y. You can easily verify this either from the graph symmetries or from the compound angle. So what's going to happen in there is you will have made zero progress, because if you look at what happens after this particular substitution, okay, you're going to get the sine of x, sorry, not the sine of x, the sine of y rather. That's from this one here. From this one you're going to get, of course, the cos of y. The cos to the 4 of this will become, of course, the sine to the 4 of y, plus this will become now the cos to the power of 4 of y, your dy, and of course, normally for those who, as I said, that they've been practicing with this, you will expect to get an extra little bit and exactly the same integral with a minus, so you can put it together and then you do your answer. But unfortunately, we made zero progress. This is exactly the same, but just in y, so this clearly does not work in here. So pause the video and see if you can have a little go at this. There's a couple of ways of doing this. A friend of mine done it in a completely different way to mine, but I think mine is, and he agreed to that. My way of approaching this is a lot more clinical than his, although I did like his method as well for variety. Okay, if you had a go and you come to the answer, I don't even know what the answer is to that. I don't remember it. Well done. If not, this is my approach to this particular integral. The first thing that I'm going to do is I'm looking at this denominator and this sine x cos x. I'm of the generation that I'm used to a lot to this kind of expansions. I'm looking for things like that everywhere. I've done that, believe it or not, when I was in year 9. Well, I wasn't educated in this country, but when I was in year 9, this is the kind of stuff we were just doing as part of our algebra. So expanding this kind of things, it was part of the regular menu. So I'm looking at things like that in here. Okay, this is related and this is related. So what am I saying in there? I'm saying the following. 0 to pi over 2. I'm going to create at the bottom a perfect square, but I got powers of 4. That's not a problem. I can write my cos to the 4 as cos squared of x, all squared, plus a sine squared of x, all squared. So I'm trying to create the perfect square. So in order to go into a bracket all squared, I need to add 2 lots of cos squared x, sine squared x. So that's there, that's there. These are added in order to make it work, and now I need to subtract it in order to balance it. And you can see these kind of things now, they're kind of related perhaps a little bit in there. Maybe it's got something to do with that. So let's continue and let's see what's going to happen. On the top, let's leave the top for the time being. I'm not going to write this as a half sine 2x, but that doesn't take long to write. All the action for the time being is on this denominator. Okay, ahead with the plan, which is of course to say this is a perfect square now on the bottom. Let's examine it. Let's write it first of all and then just check that it's all good. These 3 terms here are of course the cos squared of x plus the sine squared of x, all squared. And I've got this spare bit at the end, which I'm going to write a little bit differently. So I save myself a little bit of rubbing off and a few lines. So I'm going to write this as a half bracket. And I'm going to check it off obviously afterwards, because it's very easy to make mistakes. That's how I often make mistakes, silly things like that. I'm out by a factor of 2, or a plus has become a minus, or something stupid like that. Like here, for example, I'm just chatting now, and of course I missed a square there. So let's just check things before we go any further. Okay, this bit here is the square of this, which is there, the square of that, which is there, plus 2 times that, which is there. And this extra term, if we just check it, that's going to be sine squared cos squared, and 2 squared is 4, half of 4 is 2, so it all balances nicely. Okay, rather nice, isn't it? That's a 1, and of course 1 squared is still a 1. And let's write this line here because not a lot to write. 0 to pi over 2, and then we got sine x cos x over 1 minus, perhaps I should actually write this now, this numerator. Let me rub it off. Sorry about the squeaking. I can write it as a half sine of 2x, that's my numerator, and minus a half, and this is now a sine of 2x again, but let's not forget it's now squared dx. And let's think, what is the next thing to do? The next thing to do is clearly just play for time. So I'm going to do kind of like a very obvious step, just wasting a little bit of time. I'm going to double top and bottom of this integrand by 2 to make it a little bit neater as I'm trying to think on my next move. So it's going to be a sine of 2x on the top over 2 minus sine squared of 2x. Very annoying. Wouldn't have been nice if that was a 1. At the moment it's not a 1. So what do I do in there? I mean, at the moment I've made progress. This to this is significantly better. Is it of the form perhaps bottom differentiates to the top? Is it of the form I can perhaps do some kind of difference of squares? I can write this, I guess, as root 2 or squared. I don't particularly fancy doing that. What is my next line? The next line is kind of, I've got nothing to lose really by doing that. I like to see it. So I'm going to write this 2 that you have in there as 1 plus 1 minus the sine squared of 2x. And you can see the obvious reason why I'm doing this. Dx. And I can write this now as 0 to pi over 2 sine of 2x, and now I have this one, and of course that's now a plus cos squared of 2x. Is that better than what I had in there? I think that's a little bit better. Still not sure what to do. Okay. So we'll be doing perhaps some kind of substitution. Should we be thinking about more trig? The answer is it's enrichment, it's 5-star. So somebody who is able to do all this kind of stuff, okay, and reaches the stage. At this stage, he's just rubbing his hands and he says, game over, the game is up. I'm not going to do the substitution. You can use a substitution if you want for this particular line. You should be able to see in there. I'm going to write here a little result just to actually see what is happening in there. If I differentiate with respect to x, the arctan, because the arctan goes 1 over 1 plus x squared. So I have 1 plus something squared. So what happens if I had the arctan of the cos of 2x? What would have it produced? It would have produced, of course, 1 over 1 plus cos squared of 2x, which I'm seeing in there, times, I would have had extra bits. Let me actually write it. It's going to be 1 plus the cos squared of 2x. I'm going to move out of the way in a second. So that is arctan, and I got a chain. When I come to differentiate the cos of 2x, that will of course produce an extra negative, because the cos goes to negative, a times 2 from the chain, and a sine of 2x. Look now at my integral, and look what happens when I differentiate that. I've got everything except for this negative 2. So this is just a reverse chain rule. We kind of recognizing the differentiation that took place. So that's minus a half. The arctan of the cos of 2x evaluated between 0 and pi over 2. Let's make a little bit of space. Hopefully we can fit it in here. Let's rub off this line. I don't like these minuses. If you've seen enough of my videos, you will not have this kind of OCD. I'm gonna lose that minus and reverse the limits. So it's gonna be something like that. And towards this evaluation now. Okay, it shouldn't be too hard. Putting 0 in there, cos of 0 is 1. The arctan of 1 is pi over 4. And I have a half, so it's pi over 8 on the top limit, minus. I'm putting pi over 2 into a cos of 2x, not the cos of x. So the cos of now pi, the cos of pi is minus 1. So I've got the arctan of minus 1, which is of course minus pi over 4. So it's minus pi over 8. Careful, because it's very easy to write minus pi over 8 is equal to 0. It's of course minus minus. So it's going to be, let's write it minus pi over 8. And of course the answer to this one should be pi over 4. Okay, so this is the integral done, all in a nice way. Was it hard? Of course it was, but it was absolutely beautiful. I thought it was a very, very nice integral. Who's laughing now?